So what happened last time? So we talked about the workhorse model of neoclassical or classical economics in terms of discounted, the exponential discounted utility model. This is a very useful model for many settings. It's been very useful for explain and understand a bunch of behaviors. However, this model has a few assumptions that create sort of some predictions that are not necessarily borne out in the data. And we're trying to sort of improve on those assumptions and make the model more realistic. What are these assumptions, and what kinds of examples did I show you that perhaps were not consistent with the exponential discounting model? I'll actually show them to you, but can somebody explain to you what they are and why are those not consistent with the exponential discounting model? Yes?
You shouldn't care about whether it's today, between today and tomorrow, and then here and here and a day.
Right. So one key assumption in the exponential discounting model is that there's one parameter, delta, that essentially steers how much you care about different periods of time, the present and the future, or two future periods. The key assumption here is that how much weight you put on different time periods, on earlier and a later date, is constant across time. So from today versus tomorrow, there's the same difference compared to like when you look at like a year from now and a year and a day from now. Or like 20 days and 21 days, the difference, if you care more about the present, that's constant across time from the today's perspective, also from future perspective. That's one assumption. And what evidence did we see or show that that's not consistent with?
Like choosing a reward, you want the money now versus a day, or like you want a year, or for waiting an extra day to get that extra amount of money.
Right. So we saw some evidence that people are impatient in the short run. So when it comes to today versus tomorrow, or today versus in a week from now, people tend to be fairly impatient. They tend to discount the future a lot. Now, there's sort of two issues with that. One is if you do the same thing about asking people about future rewards, people tend to be more patient. So like the discount factors that you elicit, we'll talk a little bit about that in this recitation as well. The discount factors are just different for the same intervals of time. Second, if you take the short-run impatience seriously, if you sort of say, okay, I take your choices from today versus tomorrow, from today versus next week, and sort of just run that forward, you get sort of absurd implications, as in like if you really seriously discount like a week from now by a lot, that well then you shouldn't care about like a year from now, 5 years from now, you shouldn't care about that at all. However, we see in the real world, people care about the future a lot. People save money, people get education, and so on and so forth. So it can't be in some ways that they're really impatient in the long run as well. So that's like number one. What about point number two? Yes?
Your decision now for the future should be the same as once you actually get to that point that no new information comes about, but people don't want it to be that way.
Exactly. That's called dynamic or time consistency. That's an assumption or implication of the exponential discounting model. That is to say, if I make some choices for the future, for future periods, about how whether I'm going to study next week or in a year from now, or whether I'm going to exercise and so on, for choices that involve sort of time in the future, once that time comes, absent new information or absent circumstances change, I should follow through with my plans. And so if that's not the case, then what we say is then preferences are dynamically inconsistent. That is to say, I have all sorts of plans of exercising next week and so on. The next week comes, surprise, I'm not following through. That essentially means my preferences are inconsistent, and that's sort of evidence against the exponential discounting model. Okay. Number three, demand for commitment. Yes?
This is the idea that we shouldn't want to restrict our choices, but there are products and services that people will opt into that restrict their choices in the future, and that shows that people can know that they're bad at all.
Right. So one sort of key assumption, or one sort of like key insight from sort of economics in general, or classical economics, is like more choices are good. Like if you have like more options available, that's great for you because you can take advantage of them. You never know whether there's going to be uncertainty or certain circumstances change. So you should never restrict your choices because you never know, maybe in the future, maybe circumstances change, maybe I'll get really busy or whatever things happen. So more choice tends to be good. So in the neoclassical or classical economics model, there's no scope for and no reason to restrict your choices because more choices in the future are always good. However, if you're worried about your future self misbehaving in certain ways, if you're worried about your future self not exercising, eating too many potato chips, and so on and so forth, you might want to engage in commitment devices either by taking away certain options, just sort of like restricting your choice set to like a smaller choice set, or less drastically making future choices more expensive. That is to say, for example, if I say I'm going to submit or write a paper by the end of this week, if I'm going to tell you if I don't do that, I'm going to give you $100, well, what I'm going to do essentially is I'm making not writing the paper more expensive. Right? And the neoclassical or the classical model the exponential discounting model has essentially no scope for that. Why would I ever do that? Because who knows, maybe I'll get sick or like stuff happens. So there's no reason to do that. There's no benefit of doing that and some potential costs. So if I see myself or somebody else restricting their choices, that's a violation of the exponential discounting model. And the reason, of course, for that is number two, we know there's like preference, or if we think there are future preference reversals, if I think that in the future I might change my preferences in a way that I don't like, if I want my future self to behave in certain ways that I prefer right now, I might want to restrict my choice set, or I might certain unpreferable, like less preferable options more costly. Okay? Good. So then what we did next is to say, okay, now, so I showed you a bunch of evidence of that. And then what we did is then we sort of presented a slight deviation from the exponential discounting model, which is the quasi-hyperbolic discounting model. That model is in some sense very similar to the exponential discounting model that I showed you, except for some small difference. There's an additional parameter that's called beta. What does this beta do? It's like a short-term discount factor that essentially guides all discounting or determines all discounting between the present period, right now, versus anything that's in the future. One broad question is like, what are the time periods? Is it like daily? Is it yearly? Is it monthly or whatever? There's actually quite a bit of research on this that people try to figure this out. Usually we think the beta, the time horizon of the beta is actually just a few days, even just a few hours. Okay, so for our purposes, we can say it's like daily or today. And anything that you'll see in the problem sets and so on, it needs to be always defined. But think of beta essentially anything that's like today or in the next couple of days. Anything outside of that scope is essentially outside of the scope of beta and sort of in the future. Now, what does this beta do? Well, it helps us to separate discounting for short horizons and long horizons, because if you think about like discounting between the present and anything in the future, the beta can sort of steer that, right? If beta is like 0.7, 0.6, or 0.8 or whatever, I can now be impatient for the present. I can now prefer, say, $10 today versus $12 in the future. The beta will make sure that that happens. But when you look at all future periods, the beta is in all future periods, right? It appears like everywhere in the utility function in all future periods. So the beta does not affect how am I discounting any future time periods. So then the delta is steering that. We usually think that delta is close to 1. It's something like yearly 0.95 or 0.99 or the like. So delta is like essentially reasonably close to 1, such that I can be fairly patient between like 10 years from now and 11 years from now, even 15 years from now. It doesn't matter much to me. There's only some slight discounting. I prefer probably things that are happening 5 years from now from things that are happening 30 years from now for the same sort of stuff happening. But you know, people tend to be fairly patient. Do you have any questions about that? Okay, so let me now sort of spend, in fact, the rest of the lecture just talking about details of this model, in part sort of building intuition, sort of showing you the mechanics of how that works and how essentially having an additional discount parameter, the beta, affects people's choices. And second, we're going to talk about something that's quite important, which is the question of sophistication versus naivete. What do I mean by that? Well, in the exponential discounting model, by assumption, the preferences are time consistent. What does that mean? If I make plans for the future, I will follow through with those plans. So in some sense, it doesn't really matter what I think I'm going to do in the future, because essentially I'm going to do anyway what I'm going to plan anyway. So the only thing I need to know is like right now what I'm going to do. And then if I make that plan, unless circumstances change, I'm going to just follow through. That's not true here anymore, as I'm going to show you. So now it's the case that if I make some plans right now, these plans might change in the future because of my preferences. Like even in the absence of new information or new circumstances, once tomorrow comes or next week comes, I might sort of prefer different things. So like now the preferences are not dynamically consistent anymore. So what I prefer today might not be what I prefer next week. So that now leads to a complication. Now I need to understand, well, what are my beliefs about what I'm going to do in the future is quite important. Do I have correct beliefs? Do I understand that I'm present biased? Do I understand that in the future I might be impatient as well? Or am I naive? Do I think, like, right now I'm present biased, but tomorrow comes, or next week I'm going to exercise, do the problem set early, and so on and so forth. And as we're going to see, that will lead to quite starkly different conclusions or implications that are quite important for outcomes, welfare, and so on. Okay, so let me give you sort of some examples first. So first, if you have a discount function for beta equals 1/2 and delta close to 1, for our purposes, often I'm going to set delta to 1, not because I necessarily think that delta is 1. Delta is probably 0.99, 0.95, or the like. I'm just setting it to 1 to make the algebra or like sort of any problem set exercises and so on being less messy. Speaking of which, problem set exercises, Pierre-Luc, who sits in the very back and checks whether you are using your laptop only for classwork. Pierre-Luc is sort of mostly in charge of doing the problem sets, so he also has office hours to which you can come and ask specific questions about the problem sets. Of course, he's also very happy to answer questions about on Piazza or in any other way. When are your office hours? 1:30 on Friday, and where are they? Perfect. So it's on the course website. So if you have specific questions about the problem set, again, in the recitation, we'll discuss quite a few issues related to that. But then if you have specific questions about the problem set, Pierre-Luc will be the best equipped to answer those. Okay, so if you have quasi-hyperbolic discounting preferences with beta equals 1/2 and delta equals 1, your discounting function looks essentially as follows. The first period is sort of normalized to 1. I care like 1 about the current period. In the future, then it's like beta delta square, beta delta to the power of 3, and so on. But if you sort of now use delta equal 1, you get essentially you care about the present 1, and everything in the future is discounted by 1/2. Okay? So relative to the present period, all future periods are worth less. So I care a lot about the present. That's why we call it sort of present bias or present focus. I care a lot more about the present than anything in the future. Now, second, all discounting in this specific example takes place between the present and the immediate future. So I only care about, in terms of discounting, all future periods are the same for me. I don't care about whether things are in 5 periods or 6 or 7 periods from now. That's all the same for me, but because delta in this case is 1. Instead, what I care about is that today versus tomorrow, or today versus 3 days from now, and so on. Again, usually delta would not be 1, so if you had a delta that's like 0.99 or the like, there would be some discounting in the future as well, but not in this case. So that's sort of capturing the intuition that in the long run, we are relatively patient, right? There's essentially no discounting happening anymore. So the utils a year from now are just as valuable as utils in 2 years from now. So then that also means that the timing of decisions, or like the decisions are sensitive to the timing of costs and benefits when exactly they occur. It matters a lot whether stuff happens today versus tomorrow, or today versus 3 days from now. It matters much less about whether stuff happens in 3 days versus 4 days from now. I'm going to show you some examples of that. But just to sort of give you some sense of like why is this called quasi-hyperbolic or hyperbolic discounting. So I have here 3 functions. I'm not sure how well you can see this, but there's like a sort of pink line that's essentially like an exponential curve. That's essentially what exponential discounting looks like. Essentially what you see is like sort of a constant, if you want, sort of decline of like the discount function. And then I've also plotted to you like a hyperbolic discounting, which is essentially like a true hyperbolic curve. That's essentially the thing that you see like on the left. The one that's sort of like much steeper at the beginning. And then there's like quasi-hyperbolic discounting that's essentially quite similar in shape, as you can see, to the hyperbolic discounting, except for the fact that it's not continuous, right? There's a jump from like going 1 to beta at the very beginning. It's not a continuous function. Essentially, there's a discrete jump between today and the future, and then essentially it behaves very similarly to the exponential discounting curve. But that's just to tell you, it doesn't really, you don't have to worry about the hyperbolic discounting and so on. We're not going to sort of discuss that very much. But that's just for you to sort of understand why is that the name? Well, it's because essentially it's quasi-hyperbolic. It's not really hyperbolic because it's not really a hyperbola, but in fact it looks quite similar effectively. Okay, so then when you think about like goods that you might consume, there's different types of goods. There's leisure goods and there's investment goods. Let's sort of start with leisure goods. What's a leisure good? A leisure good is a good that has immediate rewards and delayed costs. One example would be eating candy. So eating candy, of course, you get immediate utility benefits. It's pleasurable to eat candy, so that's positive. In this case, suppose like the benefits are two, the pleasure of eating candy right now. But often, eating candy, it leads to delayed health costs or delayed costs at the dentist's office, which we can summarize as like C health of 3 in the future. If you now say, well, if beta equals 1/2 and a delta equals 1, well, you can sort of think about like, would you eat candy today or candy in the future? So first, starting off with like eating candy today. Well, if you sort of calculate the costs and benefits of eating candy, the pleasure that you get from candy is like 2. If you discount the future by beta, essentially everything in the future is discounted by beta. It's like 1/2 times 3. So if you sort of do that calculation, you get something positive. So if you think about eating candy right now, the answer is yes, because 2 minus 1/2 times 3 is positive, and you're going to do that. If instead you think about, should I eat candy in the future? Well, you get different implications. The answer is no. Why is the answer no? Because if you're in the future, everything is discounted that's happening in the future, both the pleasure that comes from eating candy next week, but also the delayed costs are essentially discounted by beta. So then you essentially just have like 1/2. This is the beta for everything in the future, times 2, which are the benefits, minus 3, which are the costs, and that's like smaller than 0, so you're not going to do that. Right? And that's sort of a general feature for leisure good, as we call them. These have immediate rewards and delayed benefits. And so what you tend to do is you tend to overconsume them in the present relative to long-run plans. Yeah?
Are you only considering 2 time periods in this situation?
Yeah, so yeah, you can think of this as like a shorthand form of saying like, for example, suppose you eat a lot of candy, or like on one day you eat candy, and suppose these are repeated choices, but I'm sort of aggregating it into one. You'll have essentially health costs in the future. Suppose you get like dental pain in the future. Each period you have like dental pain starting at age 30 or 40, 50. Now, you can sort of think of this as like each day you're going to have negative utility. What I'm doing now is I'm sort of collapsing that into one day in the sense of just making sure that to make it sort of tractable. So you can think of like the delayed health costs as like a summary of the health costs overall. Instead, you could also write down like 0.1 for year 40, 0.1 for year 41, and so on and so forth, and sort of aggregating in that way. But that's just for simplicity here. Similarly, you could also say like, each day you'll have essentially a choice to eat candy, and these things sort of add up. And again, sort of simplifying in a sense of saying like, should I eat candy overall, which is like a number of different choices that each are like between the present and the future. That's just like changing the units in some way overall. I think the structure of the problem is the same. Yeah?
So, like, obviously this is kind of like comparing like apples to oranges, but I don't know, like the one kind of like comparative problem that I see with this is like your health is kind of the sum of like a bunch of actions that like you did over your lifetime that affect your health, versus like candy is like something that like the pleasure that you get out of candy is like the exact, it only depends on the candy itself. So when people like when you do this kind of time discounting and you're trying to compare like health in the future, like pleasure now, the fact that like the candy only contributes like such a small amount to your like overall health, like I don't know, it seems kind of like an apples to oranges.
Yeah, to some degree, I think that's right. I think it's in some sense that's just an example. So I could show you many different things that are sort of similar in structure. I'm using candy just to make it concrete. You could do the same with like problem sets and other pain or like exercising and so on and so forth. I think at the end of the day, I think that's exactly right for a lot of choices that people make, be it like brushing their teeth, be it like exercising, be it eating healthily and so on. Often the costs or like the benefits are very salient and the present are very salient and concrete. Right now you have a cookie in front of you, you can eat it, you'll be happy, and that's for sure. Sometime in like 20 years from now, you might be sort of like get unhealthy, you might get like dental problems and so on and so forth. Not only is it sort of very far away, but it's also very diffuse. It's also maybe like unlikely, like, there's a chance of getting a heart attack at age like 70. Maybe, maybe not, maybe you'll be just fine. So it's more complicated in a lot of health decisions. So there's other research saying like, well, partially it's about uncertainty, partially it's about the future being like diffuse and very sort of like unclear. One part of that people tend to think is time preferences. But I think what you're saying is like the world is more complicated than that, and that's for sure true. What I'm sort of saying is like thinking about time preferences can help you understand some choices that people make over time. Having said that, there's lots of other aspects here which we're sort of grossly simplifying. But I think the key part here, I think what's really important for a lot of health choices tends to be that people, that exactly as you say, there's a lot of like thousands of like really small choices that sort of add up to something like we call it unhealthy behavior in some way. And each of them are like concrete in some sense in terms of the costs and benefits, like brushing your teeth is like costly in some sense for 5 minutes or whatever. Eating candy is like happy for a few minutes as well, very concretely. And then the costs are often diffuse in the future and so on. That's surely important. We can talk a little bit about this, but we sort of, for now at least, abstracting essentially that away. Yes?
Why this is better than the hyperbolic model, and why is it preferred to the hyperbolic model, and what actually about it makes it better than the exponential model?
So the exponential model would not predict you this type of behavior, right? So if you think about like we get to this, like if you sort of say you want to make choices for the future, the exponential discounter would give you the same choices for the future versus what actually when the future arrives. So I'm going to show you sort of more in the context of problem set. I'm going to show you there's behavior that the exponential model cannot just not explain. Like the exponential discounter would say either I like candy and I don't care about or I just don't worry that much about the health costs and I eat candy, or I'm really worried about the health costs and therefore I don't eat candy. And that choice is the same today versus next week versus 2 weeks from now and so on and so forth. So once I make a choice for like eating candy, so here notice that the person who will make the plans to not eat candy in the future, once the future arrives, that person will change their choice and then actually surprise themselves potentially by eating candy.
Yeah, I get that, but I don't understand in terms of theoretical accuracy.
There's like just behaviors in the world that the exponential discounting model cannot explain. That is one of them.
But the hyperbolic model can.
So there's so I think there's a question on like what other models can explain this. I think the hyperbolic model is in fact quite similar, as I sort of showed you in the curve here. You sort of see the discount functions are quite similar. There's research using the hyperbolic model. In economics, in behavioral economics in the last something like 20 years, the quasi-hyperbolic model is the model that everybody uses, partially for tractability and simplicity, for no other good reasons in many settings. But in some sense, what we care about, in some sense, I don't care actually that much about like which model among sort of a class of model that are quite similar can explain things sort of, if two models explain the same thing in similar ways, I don't care about which one we should use. In a sense, the simpler model is sort of easier to use, and that's why we sort of do it. What I care about is like there are some predictions from the exponential model that are sort of just not that are just false. And those we need to sort of improve on. That could be either through like a hyperbolic model or a quasi-hyperbolic model. To keep things simple, I'm using the quasi-hyperbolic model, in part because it nests very simply in the exponential model. And the reason why a lot of economists have used it is to say, okay, here's an exponential model. We know how to use that model. Now we're going to add one parameter, and things look very similar. And beta equals 1 essentially collapses that model back to the exponential model, and therefore people have used it. And that's essentially what we do. Okay, so now the flip side of those kinds of choices are investment goods. Investment goods are essentially very similar. These are goods that have immediate costs but delayed benefits. An example would be go to the gym. Like you can go to the gym right now. Like some people, find that fun, but many people also find it costly. There's some effort costs of, say, in this case, 2. There's benefits, health benefits of 3. Again, that's really sort of like a stark example, but I'm just trying to make sort of a point to make this simple. Now, again, if we have beta equals 1/2 and delta equals 1, if you think about should you go to the gym today, the answer is no, and the reason is that you put a lot of weight on the present. You put like sort of weight of 1 on the present, the cost of like -1. You put a weight of 1 on the cost of -2, so you have -2 costs. The benefits are in the future. You discount them by beta, so you have like 1/2 times 3, which is smaller than 0. Now, if you think about then, are you planning to go to the gym next week? The answer is yes. Why is that? Well, now you're essentially discounting everything that's in the future, including the cost of going to the gym. So if you think about should you go to the gym next week, the answer will be yes. The reason is because the health benefits overall are larger than the costs. Now, again, what we're going to see then is like people deviate from their long-run plans. Now they under-consume investment goods relative to long-run plans. Right? So we saw previously that people over-consume leisure goods. They do too much like fun stuff that has bad consequences in the future. And people tend to do too little of like tedious stuff that will yield benefits in the future relative to their long-run plans. Again, you will get sort of time inconsistency in the sense of like, if I plan to go to the gym next week, I'm going to say yes. Now, unless things change, once next week arrives, I'm going to be at the choice of like, should I go to the gym today? I'm going to say no. I would like to not do that because now I'm essentially discounting the future but not the present. Any questions on that? Yes.
Sorry, can you explain one more time why you discount the efforts as in the future and not?
Right. So think of these like different periods. So the effort. So if you think about should you go to the costs are today. Think about these are different periods. Period like right now. Health benefits are like say a week later. Okay. So in the choice about doing it today, the costs are right now. That's the present period. So if you go back to like the discount function, you put like a weight of 1 on anything that's in the present, and anything that's in the future period, you put in a weight of 1/2.
Okay, so because the effort is just in the future, it gets discounted.
Exactly. So the effort right now is like in the present. So start with the choice of like today. The effort is in the present. That's why I'm not sort of discounting that in the first choice for today. But if I think about doing it next week, then next week is also in the future. I'm discounting everything that's in the future, whether it's like a week away or 2 weeks ago, I don't care. And therefore, everything is discounted by 1/2. Okay. So now, one important distinction now is like demand for commitment, or is there commitment available? So what we're going to do is think about like students who have to do problem sets with like very simple beta delta preferences. So consider a student with beta equals 1/2, delta equals 1. There's 3 periods, and this is sort of getting pretty close to what you're going to do in the problem set actually yourself. There's 3 periods. You have to do the problem set in exactly 1 of 3 periods. That's of course contrived and a little stylized, but like that's just an example for now. So there's periods t equals 0, t equals 1, t equals 2. They're instantaneous utilities of -1, 3/2, and 5/2. So the problem set becomes more and more painful the later you actually do it. Okay? And there's only one day in which you can actually do it. So now the first thing we're going to think about is suppose there's commitment available. What does that mean? Suppose the student can essentially just pick when is she going to do the problem set and actually stick to that. Suppose they could just sort of dictate what she's going to do in the future. What would she choose? Well, and then she actually has to sort of stick with that. So now we can sort of think about from the perspective of period 0, remember the person is like a hyperbolic discounter with beta equals 1/2. From the perspective of right now, I'm going to say, well, the discounted utility today is like -1. There's no discounting happening for today if I do it today. For tomorrow, I'm going to discount the future by 1/2, so I'm going to get like -3/4. And in period 2, in 2 days from now, I'm going to do 1/2 times -5/2, which is 5/4. So if I could sort of predict, if I could sort of like say what I would like to do, I would say, well, I'm going to do it in period t equals 1. I'm going to do it tomorrow, and if I could follow through with that. Is that clear? Okay, so now, so that's if commitment is available. What that is if I could like essentially just force myself to do stuff in the future and not deviate from that at all. Now, if no commitment is available, how does that thinking change? Yes?
So you hit t equals 1, you change your mind.
Yes, exactly. Once t equals 1 arrives, I might actually prefer not to do it in t equals 1, but rather say I'd rather do it in t equals 2. Right? And this is exactly what you're going to see here. This is the exact same problem that I showed you before. Now suppose the student has no access to the commitment technology. It's just to say, what if the student can just choose in every period, what is she going to do? Would she actually do it in period 1? Well, if period 1 arrives, if the problem set is not done, if she does it at period 1, from the perspective of period 1, the discounted costs are -3/2. Right? That's just like because that's in the current period from the perspective of period 1. If she instead sort of were to do it in period 2, she now discounts again like period 2 from the perspective of period 1 by 1/2. So 1/2 times -5/2 is 5/4. Well, 5/4 is less bad than like 3/2. So she's going to say, I'm going to do it in period 2. So that's to say the students' preferences are dynamically inconsistent. Again, that's sort of something that the exponential discounting model would not predict or cannot explain. And the quasi-hyperbolic model is sort of one way of simply creating such time inconsistency. Yes?
I was wondering how we should think about the fact that, for example, you know that you're going to experience the disutility on the second period. So shouldn't your second period utility function be the one that matters? Shouldn't you, as a sophisticated in period 1, know that you're going to experience -3/2? That is worse than what you're expecting to experience now. I don't know if I'm explaining it right, but it's kind of the utility function should be the one that matters when you experience the disutility.
Right. So you're sort of saying, in some sense, if I understood right, is to say, and let's see whether that's true. You're saying like, well, if no commitment is available, I should never let it get to that point, right? If I'm in period 0, I should know I'm not going to do it actually in period 1. Therefore, I'd rather do it right now to avoid that I'll sort of like procrastinate it from period 1 to period 2. And if I'm now in period 0, I might say I do it rather right now because otherwise, I'm going to just do it in period 2. And from the perspective of period 0, I'd rather do it right now compared to period 2. I would prefer to do it in period 1, but that's not feasible because my period 1 self will not behave in the absence of commitment.
No, I was more thinking in a way that why would you want to commit your period 1 self, like your other self, to receive more disutility? Because you have a different utility function in that period. So if you force yourself to do something on period 1, it seems...
I mean, something that's an assumption in the sense of like, from the perspective of period 0, you make certain choices, right? You're going to say, I could do it right now, I could do it in period 1, or I could do it in period 2. Now, you have certain preferences, and you're saying maybe your preferences should be different, and that's obviously fine. I sort of specified the preferences for the student. I said their beta is 1/2, so she cares about 1/2 about anything that happens in the future in period 1 and 2 compared to period 0. And then you just look at what the utilities are, and it sort of turns out that like from her perspective from period 0, she prefers period 1. Now, you could sort of specify the utility function differently, but for that specific example, I guess that's what sort of the algebra tells us. But, yeah. Okay. So now, the key question now is to say, okay, now the preferences are dynamically inconsistent. So now what I said, well, what's really important now, and in some sense maybe you were asking about that as well, is, well, it's the question on like, is the student aware of this time inconsistency, right? So you could say, well, when deciding in period 0, you might sort of say, well, I'd like to do it in period 1. If I believe that in period 1 I'm time consistent, or like if I believe that I'm an exponential discounter in the future, I will be very virtuous in the future, well then I'm very happy to wait until period 1 and then I'm going to follow through with my plans. If instead I know that in period 1 I'm going to be present bias, well then what's going to happen is then I can't trust myself in period 1 to actually do it. I know I'm going to procrastinate further until period 2, so I'd rather do it in period 0 to avoid sort of having to deal with it in period 2. Let me sort of walk you through that. So I guess we need sort of an additional parameter to start with, which is called beta hat. Okay, beta hat is essentially the sophistication or naivete parameter. Beta hat is your belief about what you think your beta will be in the future. Okay, so beta is like what the actual beta is. Like that's the true value of beta in the present and in the future. And beta hat is like what you think your beta is in the future. Okay, what do you believe your true or your beta is going forward? It's not what you believe. You know your beta today. You know that essentially your present bias today. Everybody understands that well. That's an assumption as well. And then, but people do not know or may not know what their beta is in the future, and that's what the parameter of beta hat measures. We're going to have 3 cases. I'm going to talk about 2 cases today. There's going to be a third case starting on Tuesday. And so the 2 cases that we are discussing is full naivete. That's to say my beta hat equals 1. That's to say I think essentially I know I'm present bias today, but I think I'm an exponential discounter in the future. Okay, so that's to say I know I have like self-control problems right now, but next week surely will be different. Like, you know, this is like at the beginning of the semester, you know you're kind of like screwed up in the past, but this semester will be very different. You'll be virtuous and so on. That happens kind of every semester. So that's beta hat equals 1. So the person does not realize that she will change her mind. She thinks that she's going to follow through with her plan. Her plan is to do it in t equals 1. She thinks she's going to follow through. There will be surprises about present bias because you think you're going to do it in period 1. Period 1 arrives, and surprise, she's present bias. She misestimated what she's going to do, and then ends up sort of not doing it and has to do it then in period 2. This is sort of like false optimism, if you want, about future plans, and sort of the attitude of this time is different. You know, from tomorrow onwards, things will be very different. We'll be all virtuous in the future. Okay, and then the second part is sort of like, call it like perfect sophistication. That's beta hat equals beta. That is essentially rational expectation in a sense. This is a person who perfectly understands their preferences. I know, I've seen this movie before. I know tomorrow I'm going to procrastinate or like I'm going to be present bias. I perfectly understand what I'm going to do. And therefore, I take into account that when making choices right now. Okay, so she understands perfectly that she will change her mind. So she understands that she has plans to do it in period 1, but she understands that the period 1 self has different preferences. The period 1 self prefers to do it in period 2 rather than in period 1. So she's kind of like, in some sense, correctly pessimistic about her future self. And sort of then, in the case of like these kinds of investment goods, that's a good thing because she doesn't sort of leave stuff out. She doesn't delay things a lot for the future. She doesn't let things get bad because she knows if she procrastinates further, she'd rather do it right now, anticipating that the future self will not follow through. And here, in the perfect sophistication case, there will be no surprises. The person always follows through with their plans. The third case I'm going to talk about next week is like when beta hat equals is between beta and 1, which is we call like a partial sophistication or partial naivete. Things a little more complicated, but in fact quite similar. I think there was a question. Yeah.
The person does not realize she will change her mind, but the future self actually carries through all of the plans. It's just so that important. It's just a mistake.
Sorry, say that again.
So the person does not realize that she will change her mind over the course of the semester, but she actually carries through all her plans.
But you would not you wouldn't really carry, so if you change your minds in the future, you would not carry through with your plans.
And she does not change her mind.
So either she will change her mind in the future or not. Right? So if she doesn't change her mind in the future, there's no problem because then there's nothing to be aware of. That's kind of like the case of the exponential discounter. So if beta is actually 1 to start with, which is kind of like exponential discounting, then there's no problem because in the future she will just want the same as in the present. So then sort of by construction or by sort of assumption, then beta hat equals 1. And now if she changes her mind in the future about her preferences, essentially if her beta is smaller than 1, then the question arises, what's the beta hat? Is it like 1, that's the perfect sophistication case, or is it beta, which is, beta hat equals beta, that's the perfect sophistication case, or if beta hat equals 1, that's the full naivete case. And then there's sort of cases in between where like she does understand that her beta is like smaller than 1 in the future, but doesn't fully understand that and overestimates her beta, but at least only to some extent. Any other questions? Okay, so now when we sort of look at now, what does a naive student actually do? Well, so what does the naive student do at period t equals 0? Well, from above, we sort of know that the self 0 prefers to do the problem set at t equals 1. Right? So since she's naive, she thinks she's going to follow through with those plans. So she believed that she will actually do it at t equals 1. So she doesn't do it at t equals 0. Now, of course, what does she actually do then in period t equals 1? We already said that. She does actually not want to do the period in t equals 1, the p set at period t equals 1. So then, hence, the person sort of surprises herself and actually ends up doing it in period 2. Right? And so what's sort of the summary of that? And this is sort of more general phenomenon. If you read sort of the paper for class today, that's sort of much more general in that paper, and sort of you could do that in a much more complicated way. So essentially there's like the belief in period 0, she thinks like, well, I cannot do it right now. I can delay it. The cost of delaying it will not be that large because I'm going to just do it in period 1. But it turns out the cost of delaying is actually much larger because in period 1 she doesn't do it, she'll do it in period 2. Now if you had more and more period, you could sort of have a whole cascade of like doing it every day. You say you're going to do it tomorrow, but you're never actually going to do it. And so that can lead to actually very large costs of procrastination because you can so essentially delay things like infinitely by every time thinking you're going to do it in the future. And so that kind of behavior might persist for a long time, and it's sort of an example, as we call it, like naive procrastination. Every day you think, or every week you think you're going to do it tomorrow or next week and so on, but you're never going to actually do it. And then that can lead to really large welfare costs because there's like stuff that's actually not that hard to do, but you just don't do it every day, and it gets more and more costly over time, and you never end up doing it. And it's like way worse to do it in like 50 periods from now. You could have just done it early on if you had understood that like you were not going to do it anytime soon. Any questions on that? Yeah.
So I'm wondering, like, what's the interplay between like learning and sophistication and so like over time do people even learn that okay they are naive so they should probably be sophisticated in the decisions they make? Like, does learning become a factor?
Yes. So one big question is like, how is this even possible that we have here? Here's a person who keeps surprising herself every period, and we're like, okay, actually I thought I was going to do it, but surprise, I'm actually not going to do it. But tomorrow I'll do it. In a way, that's sort of surprising in the sense that like there are these behaviors, like for example, when people think about when do people go to bed, for example, and people think people systematically underinvest in sleep, and in some sense it's an odd sort of behavior in the sense that like you go to bed every night, you kind of know that you're going to be tired tomorrow, yet every day you sort of have this belief that like tomorrow you'll be just fine. And from tomorrow, like things will not change. So there are some behaviors where people tend to not learn, and we don't quite understand why that is. In general, sort of like learning about beta hat is sort of kind of like at the frontier of research right now. People have started estimating beta hat. They have found like people tend to be fairly naive in various situations. But then the question is like, how is it possible that people are still naive in situations where like, we're going to the gym. It's like every week you can have the choice of going to the gym. You should have learned by now what your type is in some sense, what your beta is, and you should have sort of then updated your beliefs accordingly and sort of changed your decisions. But somehow people have not sort of done that, and people tend to be naive in situations where really they have lots of situations or lots of occasions to learn. Similarly, if you think about like problem sets that you're doing, in some ways you know at the beginning of the semester kind of like what's going to happen in some way. You should know. Yet, people tend to be over-optimistic in various cases. I was like an undergrad advisor for a while, and I was sort of advising students on course choices. Every semester were the same thing. I would say like 4 classes are great, and so on. Students would take like 6 or 7. And then, I would say like, well, that tends to not end up very well. Students are like, no, this semester is different. I'm going to work really hard. It's going to be all great. And then, like a month later, we would meet, and then we would go down to 5 classes, and then be like, well, maybe 4 classes are also fine. No, 5 classes are great. And then at the end, we end up with 4 or 3. So in a way, there are a bunch of behaviors that repeat over time, and in some sense you would still think, why are people not learning? One explanation why people don't learn is like, in some sense, they don't want to learn. In the sense of like, I like to be a person. I like to think of myself as a person who is virtuous, who is hardworking, who's going to be like really doing great at classes and so on. So I want to be that person. I feel better about myself by wanting that. And therefore, I might not sort of learn as much as I could, even though that's costly for me to do. We're going to talk a little about this in terms of like overconfidence and so on, where essentially people have motivated beliefs and people want to be the person with beta equals 1, but in fact, they might not be. Okay. So now, what does a sophisticated student do? We already sort of discussed that. Essentially, the person already knows, the person has rational expectations. So the person knows that if she doesn't do it in period 0, she's not going to do it in period 1 because the period 1 self will change their minds and not follow through with her plans. So she's going to do it in period 2. Now, anticipating that, her choice is essentially effectively between doing it right now versus in period 2. Right? That's the effective choice that she has. And now, we can now like just make the choice. Does she prefer doing it in period 0 versus in period 2? Well, she prefers doing it in period 0 because period 2 is like too costly for her, even if that's in the future. And therefore, she does the problem set at period t equals 0. Okay? Any questions? Okay, so what's the summary of that? Well, the sophisticated student, for a case of investment goods, the person knows that if she delays, she'll delay even more. So like once you start procrastinating, you know this is going to unravel. I'm never going to actually do it. And anticipating that, she's going to say, well, I'd rather do it right now because I know this is going to unravel or this is going to derail in the future. I'd rather not sort of have to do it very late at nights and so on and so forth. So let me do it right now. So that student in that specific case does better than the naive student. And for the case of investment goods, sophisticated procrastination does not cause large welfare costs. It's not possible for a perfectly sophisticated person to procrastinate things for a long time and sort of lead to a very inefficient or costly outcomes. The reason being, if you know that's going to be costly in the future, if it's really that bad, you would rather do it right now. Right? And so therefore, there cannot be there can be some costs of like delaying. You might do it tomorrow. You might do it a little bit later than optimally. But it cannot be that you like procrastinate for a long time and never do it, and therefore get like really large costs of that. Okay. So one question that also came up in the online forum that you also saw in the readings, and we're going to also talk a little bit about in the problem set, is, well, is sophistication always good? And it's very intuitive to think that like sophistication always helps. After all, like knowing things better, having correct beliefs about yourself, that seems to be like the correct thing. So intuitively, it feels like that should only help, should only make things better. If I understood my biases better, I should be doing better. Now, it turns out that's true for investment goods. So for investment goods, these are the goods where you have to do something in the present, but the benefits are in the future. For that, sophistication is always better, or weakly better. The reason being that, again, like you can sort of understand your future misbehavior, and by that, understanding your future misbehavior, you can sort of avoid sort of bad things happening in the future by doing it right now and earlier. So in that case, sophistication is always better. Now, it turns out for leisure goods, that's actually not the case. So leisure goods, again, are goods where you can enjoy something in the present, and there may be some costs delayed in the future. And so let's look at, and this is very close to now the paper that you read. Suppose there's a student who has beta equals 1/2 and delta equals 1 as before. Suppose the student can go to only one movie in exactly one of the 4 periods. There's only one movie ticket that she can use in periods 0, 1, 2, and 3. By the way, Matthew Rabin is a huge Johnny Depp fan, in case you haven't noticed. So he uses Johnny Depp in various of his papers and so on. He also had a huge Johnny Depp poster in his office. The instantaneous utilities are such that they're like 1 3/4, 9/4, and 27/8. So they're sort of increasing over time, right? So if you, so there's like essentially one day where it's like the most fun to watch the movie, perhaps because you can go with your friends or like whatever, like it's a better day to do it, maybe you're a bit better rested or whatever it is. But sort of delaying would be good. Now the problem, of course, is that the person is impatient. The person might not want to wait because the person is present bias, might want to watch it earlier. The question now is, when does she actually go watch that movie? So now there's a way in which you can sort of write this down in a very simple form, which is a table of discounted utilities. That's a simple tool for solving these kinds of problems. This is supposed to come sequentially, but it isn't today, so in some sense it's already filled out for you, so that's easier for you. So what I have filled out for you here is the instantaneous utilities. So the first row here is essentially to say, these are sort of the assumptions that we have. You have the instantaneous utilities, U0, U1, UT, U3, and so on. Right, so this is essentially what you see in the first row of this table. Second, then I have filled out for you sort of the utilities from the perspective of period 0, period 1, and period 2. Right? So from the perspective of t equals 0, the first period t equals 0 equals just the same. That's just 1 because she puts weight 1 on that. But then everything in the future is like discounted by 1/2 because the beta is 1/2. Yes? Okay. And then from the perspective of t equals 1, of course, t equals 0 is sort of irrelevant because that was in the past. By definition, we only care about stuff that happens in the future because we can't change the past. Notice that's also an assumption, but it's a common assumption made in economics. So there, 3/2 now is in the present, so that gets weight 1. And everything that's in the future gets like weight 1/2, so you have like 9/8 and 27/16. And now for period 2, again, like period now 0 and 1 are in the past. Now she cares about the present period t equals 2 with a weight of 1, that's 9/4. And now t equals 3 is in the future, that's discounted by 1/2. Okay? And now what I also have done, I've like written down the ranking of these different periods. Like from the perspective of, from the sort of just looking at the instantaneous utilities, 3 is better than 2 is better than 1 is better than 0. From the perspective of t equals 0, you prefer 3 over 2 over 0 over 1. From t equals 1, you prefer 3 over 1 over 2. And from perspective of t equals 2, you prefer 2 over 3. Does this all make sense, what I've written down here? I'll let you look at this for a second. Okay, so what does the naive person do with beta hat equals 1? Yes?
Oh, wait, hold on.
We can do this step by step.
Okay, so you start at t equals 0, and then from the perspective of t equals 0, you would most prefer to do something at time 3.
Yes.
So I guess that means that you don't do it in period 1, and then you move on to t equals 1, and then again you want to do it in period 3, so you don't do it in period 1 either. And then you end up at t equals 2, and then you would rather do it in period 2 than period 3, so you do it in period 2.
Yes, correct. So let me do that in slow motion. So in period t, she makes some plans. We wrote down what is her preferred plan in period t equals 0. We have our ranking at the very right, in the last column on the right. She prefers to do it in period 3. She thinks that she's going to follow through with her plans. So she's not going to do it in period 0 because she thinks she prefers period 3. So let's just wait. Right, so she doesn't go in. She doesn't go in in period t equals 0. In period t equals 1, it's the same thing. Now she essentially says, well, she prefers 3 over 1 over 2. It's better to do it in period 3, so let's just wait until period 3. Now, of course, period 2 comes. Once period 2 comes, it turns out we cooked up the number such that like prefers period 2 over period 3. So she surprises herself by actually watching the movie in period 2. Okay? Any questions? Okay, so now instead, what does a sophisticated student do? So this was the perfectly naive student doing it and watching the movie in period 2. Now if you're sophisticated, what do you do? Yes?
She starts thinking that if she waits until t equals 2, she's going to go at 2. Wait.
Correct.
So, yeah, and so then she knows that at t equals 1, she's not going to wait until 2. She's going to...
Any help? Yes. Yes.
For the student at t equals 2, she would go. So like if she were at t equals 1, she knows that if she waits, then she would go at 2 instead of 3. But she likes 1. So like her choice is not between like 1 and 3, but between like 1 and 2. So if she were at time period 1, then she would choose to go at 1. And then if she's at time t equals 0, her choice is going to be between 0 and 1, not 0 and 3, so that if she were at time period 0, she would just end up going at time period 0.
Correct. So let me also say that a little slower again. So if we look at perfectly naive people, we're going to start from the beginning and go forwards, okay? We have like a naive person who has plans going forward, and then we can just look at how does this plan evolve. So you started, how does this person decide at period t equals 0, thinking she's going to follow through. Then we go to period 1, thinking she's going to follow through. Then we go to period 2, thinking she's going to follow through, and that's how we sort of solve the problem. Now, for the sophisticated person, we would do things differently. We essentially do is backward induction, essentially to say, let's start at the very end. The reason that we can use backwards inductions is because people have rational expectations. The person knows exactly what she's going to do. She's going to start from the end and say, okay, how is this going to play out? What am I going to do in the end? And sort of anticipating that perfectly, we're going to then solve backwards. Okay? So as you just said, in period 2, we know that she's going to go if she hasn't because she prefers 2 over 3. That's the last row that we have. She likes 2 better than 3 once she comes to like period 2. Now in period t equals 1, she knows that she's not going to wait until period 3. So period 3 is actually not an option for her. She knows that's not credible. She's not going to follow through. So then it's just a choice between 1 and 2. She prefers 1 over 2, so she's going to going in period 1. Now then, in period 1, t equals 0, now we know she realized that she won't wait until 2 or 3. 2 or 3 are not an option for her. She would actually prefer both 2 and 3, but that's not possible because her future self will not stick to her choice. So then the choice really just becomes between 0 and 1, and she prefers 0 over 1. Now essentially she goes to that movie and gets like utility of 1, but actually she would prefer any of these other outcomes. Actually any of her other self would prefer her to not do that, but she actually picks period 1. So then that's an example, and there's like several examples of that where sophistication can hurt. Now, why is sophistication hurting here? What's the key part, and like why is it worse for the student to be sophisticated? In some sense, if you think about it from the perspective of t equals 0, she would prefer 3 over 2 over 0 over 1. Or overall, if you look at the instantaneous utilities, period 2 is better. Right? So from the perspective of t equals 0, period 2 is better than period 0, yet he ends up going in period 0. So the sophisticated person actually would be better off if she were naive. If you could sort of commit to something and say, I would prefer to go in period 2, if she could say, if I only could be naive, that would sort of help her to actually do it in period 2. Of course, you can't sort of choose that, but here sort of she's worse off from being sophisticated. But what's going on here? Like, why is that happening? Yes?
So she almost mistrusts her future selves and so preempts that by taking the previous decision. But then also preempting that she would preempt her future self. She would take the previous decision again, and so that makes it so that she does the action at the very start instead. Whereas the naive person almost blunders through and manages to take the action with the higher utility.
Right. So in some ways, the problem is set up in a way that, realistic pessimism, the sophisticated person is like realistic in their pessimism. She knows essentially that in the future she's not going to behave. So she would love to wait, but what she needs to do to wait, she needs to have a sufficiently high benefit of waiting. Now, how high is the benefit of waiting? It depends on what your future self is going to do. If you only wait like a little bit, the person will say, if the choice is between 0 and 1, it's not worth waiting. I might as well go right now. So if I can wrongly sort of have the illusion to myself that I say, well, I'm going to not go in 1 or in 2 for that matter, then in some sense the benefits of waiting, the perceived benefits of waiting are higher than they actually are. And in this case, it mitigates the self-control problem or the present bias. The present bias person wants to do it right now and needs a sufficiently high reward for waiting. So if you can deceive yourself into thinking that the rewards of waiting are high, you're going to actually wait, and that's good for you in this case. If instead you're realistic about your future self, you know that waiting is not really helping you very much. You know that essentially if you wait for one period, you're going to go in the next period anyway. So then the reward, and that's in part because the numbers are set up that way, but that's now essentially sort of telling you well, waiting is not really doing very much because your future self is also misbehaving. It sort of makes it impossible to actually wait all the way until the very end. Therefore, it sort of makes the self-control problem, the present bias, worse because now it's it's not worth why even bother just to wait a little bit because that's really not worth doing. Really, what you would need is wait all the way through. Yeah.
So I think this is related to what I was trying to ask before. If you're sophisticated, you know you have a beta. If you're in period 0, you know that on the next period, your beta is not going to be there, and you're going to experience 3/2 utility, because your utility function has changed in time. Mm-hmm. So why would you prefer to experience utility 1 now, when you can experience 3/2 tomorrow? Because you know that your function is going to change.
No, but I think it's... in a way, there's a preference over, in something that's, again, an assumption how people behave. People care a lot about the present, and that's sort of in some sense in a bunch of experiments and so on. People really want stuff right now, even if they know that they will prefer stuff in 2 days from now or 3 days from now and so on. You are impatient right now, and that's what your utility function is like. And sort of you put less weight on stuff that's in the future. Now, if you sort of think about your future preferences, there's a question, and that's a philosophical question in some ways. How do you think about the fact that your future self wants something different? That is to say, for example, if I want to exercise a lot, and I also like to sit on the couch and watch TV a lot. Now, my current self wants to exercise a lot in the future. My future self wants to, and I know that, wants to sit on the couch. Now, the question is, and when you think about welfare and so on, which self should we respect? And one assumption, and this is an assumption that's built in here, is to say, my current self has certain plans for the future, and those preferences are the preferences that I'm using to maximize. I know that my future self wants other things, but in some sense, I'm assuming I know that I know better. This is the utility function that counts, is the current one, not the future one. And sort of then I respect that one, and I'm trying to maximize that, sort of subject to my future preferences being different. Right? But in some sense, you're exactly right. If you think about, should we tax potato chips, for example, we're going to talk about welfare and so on. Should we tax potato chips? You could say, well, on the one hand, I might say, I would like to tax potato chips because I know in the future I'm going to eat too many potato chips. That's good for me. But there's a future self, actually of myself, who would love to eat potato chips. That self would be really unhappy. Now, you get very tricky questions of welfare in the sense of saying, well, who are we to say that the current self is different or should get priority over the future self? The future self will really be unhappy. So there are different views on this. Some people, including Matthew Rabin, including David Leibson, and so on, would sort of say what counts is the current self, or a self that chooses for the future. That's sort of the virtuous self and so on. We should use that for welfare evaluation. That's an assumption. There's other people who would argue that no, there's all sorts of self who want different things. So if you think about, is it good to increase taxes for potato chips? Maybe, because there's like some selves are better off and some selves are worse off, and how do we ever aggregate across those different selves? So you get very tricky questions. But here, for our purposes, what we're going to do is we're going to say the current self is essentially disrespecting future utility functions and preferences in the own maximization and the maximization problem. That is to say, I have a utility function right now and sort of discounting function that tells me how I want to aggregate my future utility over time. That is what I want. And then I have essentially like a sort of like constraints which are coming in sort of in the, when I think about sort of like when you write down your utility maximization problem, there's an objective function which is my maximization problem. That's the utility function that I want right now. And then there's like constraints in your maximization problem which are, in the future my preferences will change. So some options might not be feasible because of these preference reversals and so on. But that's not to say I'm respecting the future preferences to the extent that I need to have feasible plans. I'm not respecting them in the sense of like, I know right now, I know better what's good for myself. Did that answer your question? Okay. Any other? Yeah.
Does that mean if you consume in T equals 2, you evaluate that as naive? Like no matter how you thought about it?
Sorry, what exactly is the question?
So does that mean that if you go see the movie in T equals 2,
Yeah.
do you evaluate that as 9/4 utility?
So from the perspective of period t equals 2, you evaluate it with 9/4. From the perspective of period t equals 1 or t equals 0, that is in the future, so you multiply the 9/4 times 1/2, which is the beta because it's in the future.
So then when you say like the student does better going this way or that way, are you using 9/8 as the
I'm using sort of from that perspective. So in some sense, that's a bit of a question philosophically, what's better and worse, because you have different perspective. You can take from the perspective of t equals 0. For example, the sophisticated person would much prefer period 2 over period 0 or 1 over 0, right? So I just showed you that the sophisticated person goes in period 0, and but in fact, the person would prefer 3 and 2. Right? So what the outcome of the naive person would be better for the sophisticated person from the perspective of t equals 0. Right? And so then there's a bit of a question from the perspective of t equals 2. If you had gone already in the previous period, probably prefer if you hadn't gone previously, but that's a bit silly in some sense. But you can essentially write down for each self what would each self prefer. And I think as it is in this example, it's like essentially the sophisticated essentially does worse for all selves compared to, or weakly worse compared to the naive person. Okay, but happy to talk after. Okay, so I think we have all of that. Sophistication can make things worse. So now overall, so more general, the lessons are, so the question is kind of like whether future misbehavior raises or lowers the cost of current misbehavior. So essentially, whether future and current misbehavior are complements or substitutes. So if future misbehavior raises the cost of current misbehavior, then sophistication helps in overcoming short-run impatience. That tends to be true for investment goods. That was the example that I showed you first. If I know I'm going to misbehave in the future, I'm going to procrastinate a lot if I don't do it right now, then sophistication is good because I can sort of prevent that by just doing stuff right now. So those are the investment goods with immediate costs. There's some exceptions to that, but generally that tends to be true. Now, if instead future misbehavior lowers the costs of current misbehavior, because essentially the benefits of waiting, in this case that I showed you for the movie, are just lower now, so the costs of misbehaving now have become lower, then I say, well, I might as well do it right now, or I might as well eat the cake right now, whatever, there's no point in waiting. So then sophistication hurts in overcoming short-run impatience, and that tends to be the case for leisure goods, sort of with immediate rewards. Now, yes?
Is it more about like whether utility increases than about like whether the utility
It has to. It's a little tricky. It's like kind of complicated in some sense. It has to do with specific cases. But the key question is essentially is like, in the future, does sort of sophistication or misbehavior raise or lower the cost of like future misbehavior? Does it raise or lower the cost of current misbehavior? And then depending on whether that's the case, sophistication or naivete go in different direction. Right? But so essentially there's a true answer to that. And then essentially, if you're naive to this, it sort of flips the direction depending on the numbers. But it's more complicated to that. It's sort of, these are sort of fairly general statements, so it's a little complicated. But you'll see some examples again in problem sets and so on. Yes?
Does anybody model beta hat as a function of cost?
Not so much. So usually people tend to, so that's an interesting question. So usually people think beta hat or like any preference parameters are sort of often independent of like the costs and choices that you see. So the idea often is like you are born with a beta and a beta hat and a delta and so on that fell somehow from the sky. There's some research on like how environmental factors and so on affect preferences. For example, we'll show you some research on like how contact with different types of people affect your social preferences. For example, if you are exposed to many poor people as a rich person in your life, you might become a nicer person and things like that. I'll show you some research about that. So there's some research on like how exposure to environments affects people's preferences. In the case of time preferences, usually people just think like by assumption, somehow you came with a certain discount factor, and that's how it is, or beta, delta, and so on. That applies to all sorts of settings. Yeah.
For me, usually it's like if the activity is really costly, then I'll procrastinate. So I'll act like as a naive. But if it's like less costly, usually I'll be more sophisticated. So I mean like.
Right. That's an interesting question. So that's not what people have done and thought about. In a way, there's a bit of a question whether your cost and benefit structure can explain your behavior for a given beta hat. But it might also be that, like, for some case, in some situations, you might say you want to be virtuous. For example, what I was saying earlier, it's like, why are people not learning? For some behaviors, maybe you actually don't care if your beta is like 0.7 or whatever. It's like fine. But for some people who really care about being a good and virtuous person, and therefore and these are maybe important choices in life, they would say, I'm a serious person, I do this well, my beta hat, you like to think of for yourself as your beta hat being high. That's not what people have done very much. So there's a little bit of research of like good specific discounting. Like your discounting for certain goods might be different than for others, depending on what kinds of goods they are. So some goods are temptation goods and others are not. Even that is not really in the mainstream of economics very much, let alone sort of saying like your beta hat varies by circumstance. I think that's a very nice idea. I don't know any research that has done that so far. Okay. So now one question you might ask, like, well, is it beneficial to be sophisticated? Couldn't we just all be naive and everybody's better off? So in theory, at least in principle, it's sort of unclear whether sophistication is good. As I told you, I showed you just an example. In some cases it's good, in other cases it's bad. If you think overall, like many important decisions or choices in life tend to be decisions that involve like one-time efforts that yield future benefits. These are investment goods. So in many cases in life, you have sort of investment goods, like finishing papers, presentations, reports, finding good investment options for retirement, quitting bad habits, quitting smoking, finding a job, and so on and so forth. So lots of choices are essentially immediate effort, or like, at one time or several times, like putting in effort right now where you get future benefits. So a lot of important things in life tend to be investment goods. And in that case, I guess, sophistication tends to be good. So like essentially, it helps you. Now, in addition, sophisticates take advantage of commitment devices. So I offer you a commitment device that I was discussing earlier. The sophisticated person will say, great, the commitment device might help me, great, I'm going to demand it, and might be better off because of that. I'm going to show you next week commitment devices don't always work. Maybe sometimes they could actually make things worse. But in principle, at least, you think, commitment devices could improve things, and sort of in that sense, being sophisticated is good. So I think overall, if I had to choose if I'm sophisticated or naive, I would probably choose to be sophisticated, at least in this case. Whether that's actually true, I'm not so sure. There's sort of one somewhat more subtle thing here is to say, is the issue here really impatience or time inconsistency? In the sense of, is it just about people not caring sufficiently much for the future, or is it about how important is time inconsistency? And as I said, some of the behavior that I'm going to show, that I showed you is impatience is not really the key issue here. It's not about people not necessarily caring about the future, but rather people switching their choices and choosing dominated options in the sense of overall dominated. If you sort of commit, there's some options that you prefer that you end up not choosing because you change your choices over time. Impatience cannot create this type of behavior. What I showed you where like the sophisticated person says, I would like these options, but I'm not choosing them because I know my future self will change their minds. That is not possible. You cannot generate this behavior coming from just impatience. Like a delta being like 0.5 or whatever would not generate you this behavior. What you need is time and consistency. You need essentially preference reversals over time. Okay, so then in some ways I think perhaps most practical for your purposes, in part for the problem set, how do we solve sort of problems with quasi-hyperbolic discounting? So as I told you before, for the naive person, we can start from the beginning. And why do we start from the beginning as a naive person? Why does this work? So I sort of showed you already how to solve it. Now I'm sort of generalizing that in some sense. Why is that a useful thing to do? Yeah?
Because it models how a naive person thinks.
Yeah, so the naive person thinks, I'm going to make plans now for the future. And by assumption, the naive person thinks they're going to follow through on those plans. So what you can essentially just do is you can start with like some plans, see what the person is choosing, thinking they're going to follow through. You don't have to worry about like what's going to happen in the future because you can explain perfectly what the person is doing in the present by making plans by making a choice for like the future periods. You don't have to actually worry about whether the person is going to follow through because the person doesn't even think about that. So you say, I make a plan for the future, assuming I'm going to stick through with that or stick to this. And then you can just sort of roll forwards and say, okay, I start with period t equals 0, make the plan for that, think I'm going to follow through, surprise, maybe period 1 I'm going to do something different, but then I'm going to have the same assumption and so on. I can just go from t equals 0 going forward under the assumption that I'm going to stick to those plans, right? For the sophisticated person, that doesn't sort of work because the sophisticated person knows that if I make some plans for the future, those might not be feasible because the future self will misbehave and change their plans. I know essentially that some plans are not feasible, so what I need to do is essentially need to start from the end and see, okay, if certain options are available, what I'm going to do, and sort of then walk backwards to solve it. And that's essentially sort of rational expectations, where essentially you perfectly understand your future behavior and sort of take into account your future choices. You're going to make them current choices at the end. What about the exponential person? How does that person solve the problem? Yeah?
I just had a question about what you just said.
Go ahead.
So to summarize a sophisticated person, where they're going from the end to the beginning,
Yeah.
as they move, I guess, backwards, are you just like removing choices that you know you won't ever
Correct. Correct, exactly. So what we did in the movie choice, if you go through this example in more detail, you'll notice that essentially, if I know that, for example, suppose I want to go in period 3, but I know I'm going to go in period 2 if it comes down to that, then I'm going to remove period 3 from my choice set or from my options when optimizing in period 1 or period 0, anticipating what I'm going to do in the future, right? So what about the exponential discounter? Yes? Yes. So there's two options, in fact, for the exponential discounter. It actually doesn't matter because you follow through with your plans anyway. So you could start from the beginning and just walk forward. In fact, what you can do is you can start in period 0, make a plan for everything, and just follow through. You don't even have to go to period 1, 2, and 3 because you're going to stick to that plan. So you can essentially just do that. You could actually also do backwards inductions, and I'm pretty sure you get the exact same answer. It doesn't matter. The much easier thing to do, of course, is to solve the problem in period 0, and then just assuming you're going to follow through. So, sorry, this should say readings for Tuesday. The class is on Tuesday, not on Monday. Please read the paper by Ariely and Wertenbrock. Read the entire article. We're going to discuss applications from smoking to drinking, setting deadlines, and so on, and apply these models in real-world settings. Thank you very much.